All right, in this video, we are going to talk about a plan for problem solving. In pre-algebra, we're going to be solving more complex problems than you've done before. So it's nice to just review or maybe talk about having a plan for solving more complex problems. And we're going to follow what's called a four-step plan. And the four-step plan is just a plan that we're going to use to solve problems. So here is the four-step plan. This might be good to put into your notes, so if you need to pause the video at any time to take notes, feel free to do so. The first part of the four-step plan is understand. You have to understand what the problem is asking in order for you to solve it. That's absolutely critical. So read the problem and gain an understanding of it. Ask yourself, what do I know? What do I need to find out? And is there enough information to solve the problem, or is there extra information? Sometimes we're not going to use all the information. So it's just kind of reading the problem, sorting it out, and getting all of the relevant information that we need and setting a goal. What do we want to accomplish? What do we want to solve? From there, then we can make a plan. So that's step 2. Plan, reread the problem, identify all the relevant facts. What do I need? What do I need to know? What do I need to use? Determine how those facts relate to one another. We're going to make a plan or choose a strategy for solving it. What operations am I going to need to do to solve this problem? Or maybe come up with an estimate about what you think the answer should be. And then the next step is solve. So step 3, solve it, carry out the plan, do what you plan to do, and find the answer. And a lot of us stop there and we just say, all right, I got an answer, I'm good to go. But it's important to check, reread the problem. Is there another solution? Examine your answer, make sure it makes sense, make sure it's close to what your estimate was, and just make sure you're happy with your answer. It just takes a little bit of time to check your answer, and sometimes it can save you from making a really silly mistake. So always go through and check your answers to see if they are reasonable. Now, this might seem like a lot of stuff to do for every problem that we solve. And you think, well, geez, Mr. Rudin, I can solve problems really quickly. Well, you probably go through all 4 steps and you don't even realize it. Sometimes the understand step takes 1 or 2 seconds to understand the problem, or maybe the understand and plan step take a few seconds, but you really do them in your brain, but you just maybe do them so fast you don't realize them, because these are the basic parts of solving more complex problems. So we're just going to look at some examples of how to kind of identify all the parts of the problem solving plan as we solve some simpler problems. So here we have a table of a number of teens and what they use their cell phone for, different categories of things they use their cell phone for. So the question is, about how many times as great is the number of teens who use their cell phones to take pictures compared to the number who exchange videos? So understand, what is this problem asking us? We need to find clues in the context, in the words. What is this problem looking for? Well, first of all, I noticed that we are looking for an estimate. We're not looking for an exact answer. So that's always important to identify. Am I looking for an exact answer, or am I just looking for an estimate? Will an estimate be good enough? And a really good indicator of that is this word about. About how many times is great is the number of teens who use their cell phone to take pictures compared to the number who exchange videos. So here we're looking for an estimate. What are we looking for an estimate of? We're looking for an estimate of how many times as great. That's a key phrase there. So how many times as great? So here we're talking about multiplication. How many times bigger is one thing than another? Well, what are the 2 things that we're trying to compare to one another? And so we look for the context there. We're looking for teens who use their cell phone to take pictures compared to the number who exchange videos. So now that's the only relevant information I'm looking for in the table. So taking pictures right here and exchange videos right here. So really now my plan is, how many times bigger is the taking pictures category compared to the exchanging videos category? So I'm thinking in my plan, 61 times what is going to give me about 177. So that's what I'm thinking in my head. How many times bigger is 177 than 61? So again, we're not looking for an exact answer, so we're looking for an estimate. So when I go to solve this, I'm thinking 60 times what will give me 180, because those are nice numbers that are close to the numbers I'm working with, and I know that 60 is a factor of 180, and that tells me about 3. So my answer is about 3 times as great. And then when I check, 61 times 3 is 183, and that's pretty close to our 177 teens. So again, right there, went through the 4 steps of the problem-solving plan. Again, it probably took a little bit longer than it would for you because I was explaining every step as I did it, but I did do every step in the 4-step plan. So let's look at another one. We're going to use the same data, so the same table, and this says about how many more teens in the survey use cell phones to play games than to access social network sites. So again, understand what's going on here, and again, I am looking for an estimate about how many more teens. Now this problem is slightly different than the other one, so we have to make sure we don't make a mistake and assume it's asking the same thing as the last one we looked at. So here we're comparing the teens that use their cell phones to play games compared to accessing social network sites. So I'm going to find that data, play games, and access network sites right here. About how many more teens in the survey use their cell phone to play games. So you might think, oh, it's twice as many. Well, that's not what this question is asking for. That's what the last question was asking for. So we'll have to look at the context a little bit closer. It says about how many more teens, not how many times more. So how is that different than the last question, how many more? Well, it's not asking how many times more, it's just asking how many more. So we're going to probably use addition or subtraction here. Here we're just looking at the difference between the two. So here I'm thinking 46 plus what is going to get me close to 92. And again, we're looking for an estimate here. You probably could find the exact answer just as easily, but we're going to estimate. So I'm going to estimate this to be 45 plus what is going to give me 90. And I would say that 45 more teens use their cell phones to play games as compared to accessing social network sites. And if I check that, 46 plus 45 is 91, and that's pretty close to the 92 that play games. So that makes sense in this context when I solve this problem. So again, a couple of estimating problems, and again, identifying what operations you're using to find the solution. One last one here. A rectangular garden is 12 meters long and 9 meters wide. A border is sold in 1.5 meter sections. How many sections are needed to surround the garden? So there's a couple layers to this problem. So we want to first understand what we're asking for here. So the key word that I'm seeing when I read the problem is the word surround. Surround the garden. So we're going all the way around the garden. And usually when they describe something geometrical, I like to make a sketch or a drawing. That's a helpful clue to help us solve problems here. So I'm just going to make a rectangular garden, and it told us it is 12 meters long and 9 meters wide. So I want to surround the garden. So really, what am I looking for here? I'm looking for the perimeter of the garden. So I'm trying to understand what this question is asking me. I'm going to need to know the perimeter. So when I'm making my plan, I first need to find the perimeter of the garden. So there's a couple ways you can do that. You can just add all the sides together. Remember, 12 plus 9 plus 12 plus 9, or 12 plus 12 plus 9 plus 9, or 12 times 2 plus 9 times 2, not add. And that's 24 plus 18, which is 42 meters. So the perimeter of the garden is 42 meters. That's a piece of information that I need. But that doesn't tell me how many sections of border I need. So how am I going to find out how many sections I need? Well, every section covers 1.5 meters. So how many 1.5 meter sections am I going to need to surround the garden? Well, I'm going to have to use division. So 42 total meters divided by 1.5 meters for each section. is going to give me 28 sections of border to surround the garden. And then when I check that, if I take those 28 sections times 1.5, I get 42 meters. So I know I'm going to have enough border because I have 42 meters of border, and it's 42 meters all the way around the garden. So again, going through the process of solving these problems, first understand what it's asking you, because if you get that wrong, then the rest of your efforts are going to be wasted. Make a plan. What operations are we going to need? Is this a multi-step problem? Is this a single-step problem? What operations do I need? Solve it, carry out that plan, and then check. Please make sure that your answers make sense. And that is going to be the problem-solving plan that we are going to be using.